Here, find the harmonic mean of 1, 1 by 2, 1 by 3, 1 by 4, and so on, 1 by n. First of all, let us write the formula for harmonic mean. Number of observations divided by sum of its reciprocals. Here, in this case, how many observations are there? 1, 2, 3, 4, up to n. So, number of observations is n only in this case. Sum of its reciprocals. Reciprocal of 1 means inverse of 1 is 1 only. Reciprocal of 1 by 2 means inverse of 1 by 2 is 2. Inverse of 1 by 3 is 3. Inverse of 1 by 4 is 4, plus and so on. Inverse of 1 by n is n. Now, let us consider this formula. I'll say we know 1 plus 2 plus 3 and so on up to r is nothing but r into r plus 1 divided by 2. So we are going to use this formula here. So I can write it as n divided by, instead of r, now it is n. So I will write n into n plus 1 divided by 2. I can cancel this n and this n, make this 1. So 1 divided by n plus 1 by 2 becomes 2 by n plus 1. So that's the solution for this problem. Okay, next question. If G is the geometric mean between A and B, then find the value of 1 divided by G square minus A square plus 1 divided by G square minus B square. Primarily, the question says G is the geometric mean. That means of what? A and B, they say. That means G is nothing but A multiplied by B to the power of 1 by 2 by using the formula of geometric mean. Product of the observations, here there are only 2 observations, multiplied by, product of the observations to the power of 1 divided by number of observations. Here the number of observations are 2, so I wrote it as 1 by 2. Now squaring it on both sides, we get G square is equal to AB. Now we are supposed to find out this value. What value? 1 divided by G square minus A square plus 1 divided by G square minus B square. This is nothing but 1 divided by, I will substitute this G square as AB. So AB minus A square plus 1 divided by G square again. So again AB minus B the square. Now you may notice in these two terms, what is common? A is common. So I will take A outside. 1 by A times 1 by B minus A plus, in these two terms, B is common. I will take B outside in the denominator. So you will have 1 by A minus B. Now, if you look into these two terms, here it is B minus A, here it is A minus B. So I can rewrite this as 1 by A. Let me write this as B by minus A plus, instead of writing plus, what I am going to do now is, if I take this negative sign outside, it will become minus, right? Why I am doing that? I will tell you why. 1 by B. I am going to change the signs here because I took negative sign outside. So what will happen is it will become B minus a here. Why? Because I took this negative sign outside. When I take the negative sign outside in the second term, this minus b will become plus b, positive a will become negative a. Why I am doing that? Because I want this 1 by b minus a common term in those two things. I can take that outside. For that reason, I am taking that outside. Now, we may notice 1 by b minus a is common in both. So the first term will become 1 by a, second term will become 1 by, 1 by b. 1 by b. So this we can again write it as common is AB, LCM is AB for these two. So this B will go here, A will go here. So here we have B minus A. Now this is also B minus A in the denominator. Here in the numerator B minus A. I can cancel this and this. The result is 1 by AB. Now what is AB? AB is nothing but G square. So I can simplify this to 1 by G the square. So that is the solution for this problem. Next question. I think before moving on to the next question, I will brief you about what is called as quartiles. Quartiles, what is that? Given a data, a set of observations, dividing that into focusing a central value from the first 25% of observations, you call it as first quartile. Then focusing on a central value from the first 50% of the observation, you call it as quartile 2. Then given a set of data, focusing on the central value of the first 75%, you call it as quartile 3. So there are 3 quartiles. Which are Q1, Q2. Quartile 2 is also called as median. And then quartile 3. So how do we evaluate quartiles? Quartile 1 or first quartile. Again, it is very similar to calculation of median. First step will be arrange the observations in ascending order. Arrange the observations in ascending order. Then second step, first quartile or quartile 1 is calculated as 1 by 4 times n plus 1th value. Now let us write down what do we mean by second quartile. I already told second quartile is nothing but median, so we need not write that formula. We can directly write third quartile. Sorry. So again, step 1, arrange the observations in ascending order. And then step 2 is quartile 3 now can be evaluated as 3/4 of n plus 1th value. We had already seen median is 1/2 or half times n plus 1th value. Or you also say n plus 1 by 2. That is why I'm not writing, because it is same as median. Already here I wrote it is the same as median. Now based on this understanding of quartiles, We'll now do the next question. Right. Here, the question is given as some data is given. How many observations are given? 4 plus 4, 8 observations are given. So I will say here, n, that is number of observations, is 8. We are supposed to find what? Quartile 1. For that, first we have to arrange the observations in ascending order. Arranging in ascending order, we get what? Least observation we have to write first, which is 10. The next least is 12. Then the next least is 15. Then the next least is 16. Then the next least is 18. Then the next is 20. Then the next is 23. Then the next is 28. So we have arranged the observations in ascending order now. Now let us calculate quartile 1 is 1/4 of n plus 1th value, which is 1/4 of what is n? It is 8 plus 1th value, or I can say 9/4th value. What is 9/4? 4 twos are 8. Again, 4 twos are 8. So 4 fives are means 2.25th value. Now, previously for median, it used to be 2.5 or 2 or 3.5 like that. So we used to take average. But here we may have to do the interpolation. Means this can be evaluated as second value. Means I'm splitting this 2.25 into two parts. One is 2, another one is 0.25 like this. Second value plus 0.25 times. So I will have to open a bracket. What is the next to second value? It is third value minus second value. This is the way we try to interpolate the value what is required. That is quartile 1 what is required. Means here we whatever value we write here, second if you wrote, then the next has to be written here. Suppose if this is 7th value, then here you will have 8th value, here you will have 7th value. Here it is second value, so here you write third value or second value. And second value. What is second value after ascending or after arranging it in order? It is 12. So 12 plus 0.25 times third value is 15. 15 minus second value is 12. So this is 12 plus 0.25 times 3. So what is that? It is 0.75, isn't it? 3/4. 3/4 is 0.75. So we will get 12.75. This is one way. There is another way which may be easy to understand, but if you remember this first way, this is faster. You can do it faster. Now, this is 2.25th value. Now, second value we are aware. Third value we are aware. Second value is what? 12. Third value is what? 15. So one thing is clear. Center of these two is 2.5th value. Let me write 2.5th value. What is that? It is the average of 12 and 15. 12 and 15 means it is, if I add those two, I get 27. And if I divide it by 2, I get 13.5. From where I got this? This is nothing but 12 plus 15 by 2, average of 12 and 15. So I got 27. Now I am not interested in 2.5th value, whereas I am interested in 2.25th value, which is the center of these two, second and 2.5. If I take an average of 2 and 2.5, I will get 2.25. So let me write 2.25th value. Means add 12 and 13.5 and find the average of that. How much? 25.5 divided by 2, which becomes 12.7. So this is one way which is faster. This is another way which may be easy to understand, but it is definitely not faster than the first one. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.